welcome to this ALDEC Active-HDL video. My name is Chantel, and I'll be demonstrating post-simulation debug mode. This mode allows you to simulate and debug a design without having to be connected to the simulation kernel. You'll essentially be simulating with data pulled from a database file. And this is handy because if you're doing a batch of simulations in one sitting, you won't be able to access debugging while it's doing that. But with post-simulation debug mode, you can pull the database file each simulation creates and analyze what happened after they've finished simulating. And because this mode doesn't require Active-HDL to use the simulation kernel, you can share the simulation data with other members working on the same project for them to analyze as well. So let's take a look at an example design. As you can see, I have a design called Data Path Pulled Up. This can be found by going to Help, Open Example, and it'll be under the VHDL Designs folder. This is just a general data path design for no particular device. It has a control module, a counter, ALU, mux, all the essentials for the data path. And these are the files the sample design has when the design is loaded in. We have our compile folder containing a single file, our log folder only containing the console log, and our source folder for the design files. The ASDB and AWC files here are part of the example design, as you could see by the date. I'll go ahead and right-click on the design to compile all files. For this demonstration, I didn't enable debug for compiling because all the tools that debug enables are not usable in post-simulation debug mode. This includes setting breakpoints, using advanced data flow, and stepping through code. Since compilation was successful, we can now change some of the design's settings. Just right-click on the design name and click on Settings. Here, we will edit some of the simulation settings to get the simulation results we want. In the Access to Design Objects section, enable Read Access by clicking on this checkbox. I'll leave the options below empty. That way, all the design regions and objects will be read accessible. Then in the Trace Debug section, I'm going to enable saving of full signal history. Enabling this allows me to store all of the selected signals events during simulation, which will allow me to navigate through a signal's simulation history during the current simulation run and in the post-simulation debug mode. And once this is enabled, I can also select more signals to save their history. By default, only the top-level signals are saved, so I'm going to also include all signals in data path, hit OK, then Apply, and then OK again. These saved signals will appear in a PSL file in the design's main folder. And this file will be used for post-simulation debug mode to determine which signal values can be viewed. With the settings changed, we can now initialize the simulation. In this case, make sure that Top Test Bench is set as the top level, and then click on the Initialize Simulation button. Now, one helpful thing to note is that you can save a signal's history for post-simulation debug outside of the PSL file. To do that, just open up the waveform viewer, head over to the Structure tab, and add your desired signals into the waveform window. I'll go ahead and add the control signals. And with all my desired signals added to the waveform and PSL file, I'll go ahead and run the simulation. All test vectors are simulated, so I'll end the simulation. When simulation ends, I should now have a new file saved in the design's source folder. Remember from earlier that the source folder only had a pre-included ASDB. But now, we have a wave.asdb file that was saved from the simulation run I just did. This is an ALDEC simulation database file, and it's a binary file that stores the simulation data collected. And by default, it saves it as this wave.asdb file. So now that we have our ASDB and PSL file, let's finally go into post-simulation debug mode, or PSD mode for short. To go into this mode, head over to the main bar and go to Simulation, and click on Initialize Post-Simulation Debug Mode. I'll use that wave.asdb file, and now notice that the console says that simulation has been initialized. This means we're now in PSD mode. In this mode, you can view the stored simulation data through the waveform window, watch window, block diagram editor window, objects list, and memory viewer without running the simulation kernel. I'll first open up the waveform window and add my top-level signals to the waveform. Also, as I've shown earlier, even though the PSL file doesn't contain the signals from the control unit, I'm still able to add them back into the waveform viewer because I added them to the waveform during the simulation kernel run. I can even add the control signals to the watch window, or even one of its signals to the memory viewer. The same cannot be said for the signals that weren't added to the waveform nor the PSL file. If I try to add ALU signals to the waveform, for example, I get an error in the console stating that the object was not found in the database file. It's the same thing if I try to add one of its signals to the memory viewer. I can still add them into the watch window, but I'll get no values no matter where I navigate to in simulation time. So if you want a signals history for post-simulation debug, make sure to select them in the traced debug settings, or have them added to the waveform viewer during your simulation kernel run. Now I'll delete all the ALU signals in the watch window and add the control signals in. I've been using the waveform viewer's cursor to move around simulation time, but you can also use the move backward and run for buttons as well. As you can see, the signals are seamlessly updating in the watch window and waveform window. The memory window updates also as I move forward or backward in simulation time. The block diagram editor updates for the selected signals, and all the other unselected signals have a question mark in them. As a final note, if you hover over one of the saved signals in the HDL editor, you'll get a tooltip that shows the value of that signal at that simulation time. And that's about it for post-simulation debug mode. Again, not needing the simulation kernel means you can transfer these data files to another system or share them with your project members, and they'll be able to view the simulation data in PSD mode too. The essential debugging tools like the waveform viewer become accessible even after simulation has finished, making debugging only in the moment a thing of the past. Thank you for watching.